welcome to Tech Tuesday at the Allen Park Public Library. I'm Mad Dan. Last time we talked about pressure and how water and air can do odd things. This week we're going to be talking about density. This is still our summer reading program, and the theme this year is Imagine Your Story. The story we're looking at is The Princess and the Pea, and how having one really dense little object can affect everything above it in really odd ways. In that respect, we're looking at 3 different liquids and 4 different solids, and we're going to stack them just like those mattresses to see what happens, what will sink, what will float, and what will be somewhere in the middle. In addition to that, we're going to be looking at how temperature and density are related by taking hot water and cold water, mixing them together, and seeing what happens. So, let's get to it. We have our 3 liquids here. We're going to start off by taking the tap water. We've just put a little bit of food coloring in it, but it's just regular tap water. And we're going to pour it into our mixing jar. So, we've got a nice little pretty blue, that's why we added the dye. Next, we are going to take some syrup. And the syrup is going to cut right through that water, and it's going to make a nice solid layer right on the bottom. The syrup is much denser, it just falls right through the water. Lastly, we're going to take our cooking oil and pour a bit of it in, and you can see that it does, because of the weight from the gravity, it falls down and goes in a little bit, but then it separates, rises right to the top, sits on top of the water. So here we have our 3 layers: oil, water, and syrup. And then we're going to have our 4 objects. Depending on how dense they are, they're either going to sink through a layer or float on top of a layer. We're going to start off with our piece of metal hardware. It is, unsurprisingly, quickly sinks all the way down to the bottom, and you can see it just right off there to the side. It is like a rock sitting on the bottom of the syrup. Next, we're going to take our die from a board game, plop it in, and it is heavier than I thought that it was. So, the light syrup that we were using today is not as dense as normal maple syrup. So the dye, which I expected to float on top of the syrup, sank to the bottom. But that's part of the fun of science, that's the fun of experimenting, and when using household ingredients like this, it's safe, and the worst that you can have is an unexpected accident. So I went and grabbed a couple other objects, and we're going to see what happens when we put all of these in. So we're going to start with the bottle cap. So we drop it on, floats on top of the oil. But does it really, or is it just buoyant? So we fill it up with a little bit of that oil, and sure enough, it sinks in the oil, but sinks into the oil, but not all the way down to the water, but it is still under the surface. Let's take a little bit of household chalk. Again, sinks in a little bit, but mostly on top. And then that last cork that we were going to use rests almost entirely on the top. The cork is not dense at all. It rests there on the top, sucks up a little bit of the oil because it's porous, and here we go. We've got some objects. Let's just drop that final spoon in, and it just goes all the way in. So all of this, the syrup, the water, the oil, all very safe, all easy to clean up, and this is the fun of science. So now we're going to move over to the temperature experiment. Just as different objects have different density, temperature affects density as well. Here we have hot water and cold water, food coloring added to make them look different. The hot water is much less dense than the cold water. If we were to just take the 2 and pour them into the jar, that's not going to show us anything. Instead, what we need to do is find a controlled way to do it. So we take this card, and using the pressure things that we learned from last week, we're able to use water pressure and air pressure to keep them separated. We're then able to put this jar on top of the other one, and then with assistance, either an adult or another relative, hold the 2 jars together and have the second person pull the card out. We can see what will happen if the hot water has to go into the cold water, or if we flip them around and see the cold water going into the hot water. So, this cup is filled with cold blue water. This jar is filled with hot water. What I'm going to do is I'm going to put this card on here, creating a tight seal between the water and the card, and then quickly flip it over. The seal maintains and holds the card up. What we're going to do now is we're going to put this jar of cold water over this jar of hot water and remove the card. You'll be able to see visually as the waters combine and the hot water goes up, you'll see the bubbles. Normally bubbles in water is air. In this case, it's only water. Both of these are filled entirely, and you'll see the hot water displace the cold. Now, have a parent or older relative help because the hot water is very, very warm. And you want to hold the two jars together as the card is removed. So you can see the hot water go up the right side, the cold water went down the left side, and now, because the hot water is thinner and less dense than the cold water sank into it, the hot water rose, and now this is warm and this is cool. If we do the other way around now and put the hot water on top, again, parent or older relative, the hot water is a little dangerous. We will see what happens when we remove the barrier. The hot water no longer has to rise through the blue cold water, so instead of blending together, you can see a little band of purple in the middle, but in general, the hot red water stays completely separated from the cold and heavier blue water. Whether your experiments turn out exactly how you thought they would or not, the important thing when doing this kind of science is to be safe and have fun. Use a parent, use a relative, work together, learn something. Thank you for joining us on Tech Tuesday at the Allen Park Public Library. I've been Mad Dan. See you next time.